So this section is again 4.3, and it's solving the systems of linear equations by elimination, but you would have to multiply before you could apply the elimination. So let's take a look at this example. Let's say we're doing 5x minus y, and that's equal to negative 11. And then we have 2x plus 3y is equal to negative 1. Now if we go ahead and add these two equations together, neither one of the variables will be eliminated. 5x plus 2x is 7x, negative y plus 3y is 2y, so neither one get to multiply. So our first step when that happens is to think about how we could make one of the variables the same but opposite in sign. So when you add equations together and neither variable drops out, you must multiply to make one of the variables the same but opposite in sign. Okay, so take a look. I see automatically that the y's have opposite signs already, where the x's do not. They're both positive. So I would think it would be nice to take this equation here and multiply it by 3. Because if I multiply by 3, this y, which is negative, is going to become negative 3y, and then these two will be opposite. So, but I have to distribute to all of it. Okay, so that means I get 15x minus 3y equal to negative 33. And then I bring the other equation down because I don't want to change it. Okay, and so now when I add the equations, the y's will drop out. So I get 17x equal to negative 34. Now divide by the 17, and so I get x equal to negative 2. So now my second step was I just did it. I solve it for one variable. And now my third step, which I'm doing next, is the solution you put back into the original equations. So you put them back into either one of these. I tell people to do both because then you should get the same y value and you know that you did it correctly. So I've got 5x, but I know what x is, so I'll back that up. So I have 5 times negative 2 minus y equal to negative 11. So it's negative 10 minus y equal to negative 11. If I add, I get y equal to, because that's adding 10, I get negative 1. And so y is 1. Do the same thing, but with the other equation. 2 times 2 plus 3y equal to negative 1. 4 plus 3y equals negative 1. So I'm going to subtract, oh, I'm sorry, this is negative. So this is negative. So I'm going to add 4 to both sides. So I get 3y equal to 3. And so y is 1. So my solution is negative 2, 1. And it worked. I got the same answer for both y values. So I know I did it correctly. So that's the kind of the idea how you do that. Let's do a different problem. Let's say you have 3x plus 2y equal to 1, and then the other one is 2x minus 3y equal to 5. Okay? So right away, I can't eliminate by adding both equations together. So I can see I can eliminate the y's since they're both opposite in sign. So I'm going to multiply this one by 3, and I'm going to multiply this one by 2, because then 3 times 2 is 6, and 2 times negative 3 is negative 6. So they'll be opposite in sign. So I'd get 9x plus 6y equal to 3. And then I get 4x minus 6y equal to 10. So now when I add the two y's, I get them to be eliminated. This gives me 13x, and this gives me 13 by adding. So x is 1. So now I'm going to put them back into the original to see that I get the same answer. So 3 times 1 plus 2y equal to 1, and 2 times 1 minus 3y is equal to 5. So this is 3. Move it to the other side, that's minus 3. So that makes it 2y equal to negative 2, and so y is negative 1. So if I do that for this one, that's 2. Subtract it, I get 3, so that's negative 3y equal to 3, and so y is equal to negative 1. So my solution is 1 comma negative 1. And this is how you do it all the time. You're always trying to pick one of the variables to eliminate. And if you see one that's got positive and negative, that's kind of the easiest one to do out of the two. But sometimes that doesn't happen. But that's what you do. You want to solve that for that whenever you have, when they don't drop out when you're adding the variables together.